Okay, so as I said, the first one that we'll do is number 58 from chapter 4. So 458. And let's see, a rotating fan completes 120 revolutions every minute. So 120 revolutions in 1 minute. Consider the tip of the blade at radius 15.15 meters rather. So here's a blade. Maybe it's a fan that looks like this, but 0.15 meters, that's the radius, so this blade would be rotating around. But you can see that okay. 0.15 meters is the radius. Good. Through what distance does the tip travel in one revolution? Good. Well, we know the time it takes for one revolution. We could rearrange this equation to get that. So it's 1 minute for 120 revolutions, and 1 minute is 60 seconds. So it takes a half a second for one revolution. So that's the period. That's the time to go around once. And we can figure out how the distance that this point travels. Maybe it's this point here. It's going to go all the way around the circle. So it's going to travel a distance of 2 pi r. That's the distance it travels in a certain amount of time. The period. That's what this represents here. 0.15 seconds. Good. So this is the speed. 2 pi r divided by t. Let me go back to this side. So 2 times pi times r, 0.15 meters, and divided by 0.5 seconds. So I'll let you figure out what that number turns out to be, but that is the speed. Oh, sorry, actually that's part B. What is the speed? Through what distance does it travel? That would be the top part here, 2 pi r, the circumference of a circle. So part A, that's the distance it travels. This whole part here is the speed, the distance divided by the time. And then part C, the magnitude of the centripetal acceleration. So again, some people call it radial acceleration, some people call it centripetal acceleration. You have everything to do part C, v squared divided by r. You know what v is now, the speed from part B. You know the radius is given in the problem, so that's part C. And then part D, what is the period of the motion? Well, actually we got the period of the motion to begin with, 0.5 seconds. Great, so that completes number 58 of chapter 4.